Hello and welcome. We are glad you have joined us. My name is Marco Estrada. I'm a Microsoft Technical Trainer specializing in Microsoft Azure infrastructure and security. I'm here to walk you through the AZ-700 course, Design and Implement Microsoft Azure Network Solutions. In this session, we'll cover the introduction to Azure Virtual Networks. In this video, you will learn how Azure networking fits together, from building virtual networks and IP addressing to DNS resolution. You will also learn how to connect networks with peering, control traffic with routing, and manage outbound connectivity using Azure Virtual NAT, so you can design networks that work reliably in real deployments. Let's get started. The first section of this video is Design and Implement IP addressing for Azure resources. What we're going to learn, it is about reviewing network fundamentals, a little bit of IP addressing fundamentals, planning for Azure IP addressing, having some demonstrations around it, and examples of public IP addressing. Let's review virtual network fundamentals. First, you need to have a virtual network. A virtual network is the main boundary of a larger IP address space. So you can deploy a virtual network within a region in Azure, and within that virtual network, you have subnets. Subnets are smaller divisions within your VNet, where you are going to start putting your resources. So each resource in here will have a unique IP address. And remember that we are going to follow the CIDR notation, which is the classless interdomain routing, which defines the size of your address with the subnet mask. Within the IP addressing fundamentals, remember there are certain IP addresses that you cannot use. Normally, the first IP address in your subnet, the last one as well, cannot be used. Then later on, the second one that it relates to the gateway of your network cannot be used as well. And then we use the following third and fourth for DNS placing. So also remember that you cannot use multicast, broadcast, loopback, blend local networks. Also, the internal Azure DNS cannot be used as well. So in order to use a virtual internal network, you need to follow the RFC 1918, which defines which type of internal network you can use. So for example, 10, 172, and 192. Let's talk about planning your Azure IP addressing. First, if you want your virtual networks to communicate with each other, make sure that their address spaces don't overlap. Also, try to plan for bigger virtual networking instead of a lot of smaller ones. Also, you need to decide if your Azure resources are going to be available only internally, or also they're going to need a public IP associated to them. And also you need to decide if that IP address spaces are also going to be static or dynamic. Subnets shouldn't cover the whole subnet or the whole address space for the virtual network. And last but not least, remember, please do not change the IP address settings within the virtual machine. Now let's take a look on how to create a virtual network and how to add subnets to that virtual network. In this demo, we're going to create a new virtual network. Right now, we're at the Azure portal in the Network Foundation view. In this view, you can check all the different virtual networks, private links, DNS, monitoring, management things we're going to cover. Later in the course, we're going to click Virtual Network Overview. In here, you can see other things that are related to virtual networks. And our purpose today is just to create a virtual network. In here, the first thing that we need to describe is the subscription and the resource group. In my case, I'm going to use my demo subscription and the resource group courses. So these will be used during other videos as well. I'm going to create my first VNet. I'm going to call it VNet Hub because that's where I'm going to put all different things during this course, and I'm going to keep the region as West Europe. Later on the next tab, we're going to see different things related to security. These other services can be enabled right now, or you can enable it later during the course. Next, I'm going to define the address space. So we get a default address space, which is 10.0.0.0/16, which is good enough to our purposes. Then, later on, you will see different subnets that are created. By default, you get the 10.0.0.0/24 as the default address space for this subnet. You can add more subnets in the moment of the creation of the virtual network, or you can create other ones with different subnets. You can create subnets for different dedicated services that we're going to need, and if you scroll down on the creation of the subnet, you will also see that we have other options, like private subnets, service endpoints that we are going to cover later on this course as well. For now, I think that having that subnet in the address space of my VNet will be enough for my purposes. You can also add additional address spaces if you need to. You can add IPv6 as well into your VNet. So let's create the virtual network now. Once the virtual network is created, we can go directly to the VNet to review the different configurations that we chose on the previous page. So in my case, I selected the address space 10.0.0.0/16 for the whole VNet. I also chose Western Europe as the location, and within subnets, I have one default subnet that is 10.0.0.0/24 that it gives me 251 addresses available. Remember that we have 5 addresses reserved for Azure, and that's the reason that you see a little bit less. So we're going to add another one for Azure Firewall Management and Virtual Network Gateways, since we're going to use them later on. So when I choose that one, it names automatically the subnet as Azure Firewall Subnet. It fills some of the configuration sizes for that specific subnet, and the only thing that I need to do is to add it to my virtual network. I'm going to repeat the same task for the management and for the Virtual Network Gateway. And with this, we finished this demo. Let's go back to the presentation. Sometimes your Azure resources are going to need access from the internet. In these specific cases, you will need a public IP address. This address can be assigned to a virtual machine, a load balancer, a network gateway, or even a firewall. Sometimes you're going to need a range of reserved IP addresses from Azure. So in those cases, you will need a public IP address prefix. Now let's take a look on how to create a public IP address. In addition to that, we're also going to create a public IP address prefix. In this demo, I'm going to create a public IP and a public IP prefix. I'm at the virtual network overview, so I'm going to scroll down a little bit to find the public IP addresses. I'm going to create one, so I'm going to choose my resource group where I have all my resources, select the region that I want for this public IP, in this case, West Europe. And then later, I'm going to name it properly. So this will be used for my virtual machine that I have in my environment. So I'm going to call it VM0 public IP, and I'm going to choose IPv4. You can choose to use IPv6 if needed. The SKU standard v2 is currently available only for NAT gateway. This is something that we are going to talk about a little bit later. In my case, I can choose potentially the zone where my virtual machine is located, or I can just keep it as zone redundant. Also, in the case of the tier, I can choose either regional or global, but global are normally used for global load balancers. So it is fine to keep it as regional. In the case of routing preference, I'm going to choose Microsoft Network if I want to select one of the different point of presence that Microsoft has around the world instead of using my internet service provider. I'm also going to use the DNS label because I'm going to use it a little bit later in this course. Next, we have the distributed denial of service protection, which will help us protect this public IP. I'm going to keep network selected in this case since we're going to learn about DDoS later in this course. For now, we're going to create a public IP now. After the public IP is created, we're going to go to the resource, take a look at the different values that we got. This is the IP address, the DNS name, and what I'm going to do is I'm going to associate it now to my virtual machine. So in this case, I'm going to select network interface. I'm going to look at the different network interfaces that I have. In this case, virtual machine 0. I'm going to click OK. Another thing that I need to do is that I'm going to copy the public IP address because I'm going to use that IP to connect to the virtual machine itself. So here, I'm going to click Properties on this virtual machine, paste the public IP that I got from the portal, and just double-click to connect. And that seems that is working correctly. So let's go back to the portal and create a public IP prefix now. A public IP prefix is a group of public IPs. Sometimes I want to have a continuous public IP address space, not one by one like the one that we were creating just now. And that's the reason you want to create a public IP prefix. So we are going to create one for public IP addresses. So let's choose courses and we're going to call it public IP prefix. And we're going to choose West Europe as before. And we're going to choose standard IPv4. The prefix ownership is interesting because we're choosing Microsoft owned because we want Microsoft to give us, for example, the public IP addresses. But you can also bring your own custom IPs if you already bought some of your internet service provider and then you want to use it within Azure for your different resources. I'm going to keep the tier for regional, Microsoft Network for routing preference, and zone redundant for availability zones. So let's create the public IP prefix. After the public IP prefix is created, you can choose to either create individual public IPs like the one we created before, or you can use a whole prefix for a specific solution like a standard load balancer or maybe a NAT gateway. So for this example, I'm going to use one of the public addresses that is included on this prefix. So this will add a public IP address. In my case, I'm going to name it public IP from prefix 1. That's going to be my first public IP from here, and I'm also going to probably use that DNS label for other purposes later on. So there you go, we're saving that public IP. We're going to repeat the same exercise for another public IP. And when it's done, we're going to review it in the public IP addresses. So this is the one that I just created. So I'm going to go back to the overview, create another one, let's say public IP prefix 2, and I'm also going to create it. And with that, I'm going to end this demo. So let's go back to the presentation. In this part of the module, we are going to talk about design and implement name resolution. We are going to review DNS fundamentals, also understand a little bit of the Azure DNS capabilities, create a public and a private DNS zones and its DNS records, and finally explain what is a DNS private resolver. DNS stands for Domain Name Service. So you have a DNS zone which hosts DNS records for a particular domain. when these records are called, for example, www.contoso.com, you get a response. So in that sense, that is a DNS resolution. So you can translate a name to an IPv4, an IPv6 address, or a name to name. Azure DNS presents us with multiple capabilities. One of them is to resolve the names from the internet with the public Azure DNS. Sometimes we need that capability for our internal networks, so we have the Azure private DNS. Or maybe you need to have that resolution when you're asking from on-premises networks to Azure or vice versa. That is going to be the Azure private resolver. If you want to host your public domain in Azure, you need to create a DNS zone. It is very straightforward to create one. Just go to the Azure portal, add your domain name, and then later add your records to it. But remember, there is one thing that you need to do first. You need to change your internet register, the place you buy your domain, to point to the Azure name servers in order to use it. We're going to see that in a bit. In case you want to use your own private domains, you can create an Azure private DNS zone. Just go to the Azure portal, add your domain, and then start adding your records to it. Also, there is an option for you to auto-register the Azure resources. So the idea is that your virtual machines within a virtual network can resolve those names. But remember, you need to link that private DNS zone with the virtual network in order to work. So now let's take a look on how to create a DNS zone, add a DNS record set, view the name servers, test the resolution, and explore some of the DNS metrics. In this demo, we're going to create a public DNS and a private DNS zone. Here we are at the Network Foundation blade. At the DNS overview, we see the DNS private resolver that we're going to cover in a bit. But for now, let's create the first public DNS zone. A public DNS zone is going to be available for everybody to use in the internet. So we're going to select the resource group for this public DNS. We're going to name it saba-corp.com. And next, we have the DNS zone editor. And in here, I can upload my DNS zone file if I already have one in my environment and I'm just migrating here. So we can just upload that. In this case, we're just going to leave it empty. So let's review and create this DNS zone. Once it's created, we're going to go to the resource and we're going to create a new record set. And within the record set, we're going to add, for example, www.saba-corp.com. And what we can do now is that we can point that specific public IP that we created before, so we can use it with the www.saba-corp.com for that specific IPv4 address space. So we have different types of record sets that we can use. We have, for example, IPv6, certificate authorities, name to name, mail exchanger, name server, SRV, TXT, and pointer. So let's just keep it IPv4, and in here later on, we're going to add the public IP address that we created before. So let's add that record set. Once it's done, I'm going to be able to resolve this name. Now let's go back to the virtual machine that we connected before. And what we're going to do now is that we're going to do an NS lookup to that specific domain name that we have now. So this domain name already exists in the internet. So when we do an NS lookup, we get a response back from it. Probably it might or might not have a www, so it seems that it doesn't have it. But I do really create it, isn't it? So what I need to do in my environment, I need to go to my internet register to change where my domain name is hosted, in this case, the Azure name servers. So you need to take a closer look to the different name servers that we provide to you, so you can provide them as well to your internet name register. In this case, we have a .com, .net, .org, and .info. And the idea is that you add all the 4 of them so you can have any of those responding to your queries to your DNS zone. So let's copy, for example, the .com. Come back to the virtual machine and try to do the same resolution. But now we're going to do is that we're going to ask to that specific Azure DNS name server. And now what it comes back is the public IP address that we just added in the previous record set. So we can later test it out. Now let's create a private DNS zone. Let's come back to the Azure portal and let's go back to the Network Foundations DNS overview and create a private DNS. The private DNS, it is going to be available only to the virtual machines in my environment. It is something that we normally use in our environments to locate local resources. So in this case, for differentiated with the public DNS zone, I'm just going to call it Zava.corp. I have the same DNS zone editor if I needed to. But there is a difference between the public and the private DNS, right? And the difference is that in here, we need to define a virtual network link. So we're going to associate this private zone to a specific virtual network. In my case, I want to associate it to my hub virtual network that we created in a previous demo. So this is the VNet Hub example here. And I'm going to enable also auto registration. So what is auto registration? It is going to take the different resources on that specific virtual network and it is going to add them directly into the private DNS zone. So let's create that now. After the zone has been created, let's go to the resource. Take a look at the different configurations here. So as you can see, there are no name servers allocated here because this is not a public but a private DNS zone. And the record sets now will include my virtual machine 0, the one that we were playing around with before. And what I can do just like before, I can create a www, or maybe now, since this is a private DNS zone, I'm going to call it intranet.zava.corp. And I'm going to associate that record set with the IP of my virtual machine, which is 10.0.0.4. I'm going to add that into my record set. And since I did link this to my virtual network hub, that means that my virtual machine, which is also hosted in a specific subnet, will be able to resolve this name. So in this case, I don't need to specify any DNS because it's going to use the Azure associated DNS. And what I'm going to do, I'm just going to put a proper Zava.corp and just going to do that. So in this case, it's still not available. So let me check if the zone has been associated correctly. So the domain name is correct and I have the different record sets. Oh, it's because I named it intranet and not www. So let's try it again one more time. And with that, now we can see that is the 10.0.0.4 that is the one that is resolved in my own private DNS zone. And with that, let's go back to the presentation. When you're resolving private domain names, you can use virtual machines to do that job. But instead, how about we use the Azure DNS private resolver? So when we create this type of resource in Azure, so you need to create an inbound endpoint, an outbound endpoint, and then create the rules to that resolution work for you. In this section, we are going to talk about design and implement virtual network connectivity and routing. We are going to cover virtual network peering, system routes, user-defined routes, what is an Azure route server, Virtual Network Manager, and what is an Azure NAT Gateway. What is virtual network peering? Let's imagine that you have two different virtual networks and that you want to communicate those virtual networks together. The virtual networks can be in the same Azure region or can be in the different Azure regions for that matter. And what you need to do is that you need to just enable that setting. With the virtual network peering, you can also enable the gateway transit, which will enable you to communicate to other networks like on premises. Also, now you can do peering with subnets. So you can now choose between peering through an entire virtual network or just peering to a specific subnet in Azure. Now let's see how to create a virtual network peering, explore the settings, and test the peering. In this demo, we're going to create a peering between virtual networks and explore and test those settings. In my environment, you'll see that I have a hub network where is my virtual machine 0, and I also have another network where I have other virtual machines. So I'm going to connect this for the purposes of this demo. But before doing that, I'm going to show you that we don't have connectivity between these two networks. So I'm going to try to ping the IP address of that virtual machine, and that request will time out. And that we're going to do later on, we're going to enable this communication with the peering. So let's go back to the Azure portal. Select the virtual network where do you want to have the peering. Scroll the features, select peerings, and in here, I don't have any peering. So let's add a new one. So we're going to name the remote virtual network. In this case, we're going to connect to the spoke network, so that will be named as the hub, because that is going to be, let's say, the remote connection. So that's going to be the spoke one to have peering, and I'm going to select that specific virtual network. In this case, will be the spoke one. And as soon as I do that, the settings of the peering change with the proper names. So I have allowed the spoke to access the hub network, and I can also allow the scope to receive forwarded traffic, which is another different network not directly connected to it. I can also use the gateway or route server also to use it. In this case, I do not have one, so I'm not going to select it. We're going to create one later on. Bear in mind, like I said in the presentation, that if the virtual network has the same or at least overlaps the address space, even if it's a small subset of it, you're not going to be able to have the peering. So make sure that your virtual networks don't overlap in order to create the peering. So this is the remote configuration. Now I'm going to create the local peering link name. So that's going to be the hub to spoke one peering. And as I said, so this now does the other way around, right? So I'm going to allow the hub VNet to access the spoke VNet because in the previous one was the other way around. So this is a bidirectional configuration, and these two peerings that I created at once are going to be added, one of each of the different virtual networks. So what we can see that is that in my VNet hub, I have this hub spoke 1, which is fully synchronized. What that means is that all the routes are in place. And I see that the configurations that I selected are in place, which is only the first one to allow this bidirectional communication. And also, if I go now to my spoke network, I'm going to see that the peering was created automatically for me. If you don't see it immediately, it is just about a refresh that you need to do. You see that this is a spoke 1 to hub, and then again, you can also take a look at the different configurations that we selected when we were creating the peering. So let's go back to the virtual machine and just give it another try. And now I can see that I'm able to communicate to the virtual machine in the other side of my peering. So with that, let's go back to the presentation. System routes are automatically added to every subnet's route table. When you created your virtual network and defined your address space, that it is added to that system route. When you create a peering, the address space from the other virtual network also gets added to that system route. You also have a system route to go out to the internet. You cannot delete system routes though, but you can override them with user-defined routes. UDRs are implemented in Azure as route tables. So the idea behind the user-defined routes is to override the default system routes. When you create your route table, you need to define what is going to be the next hop or the next jump to be maybe a network virtual appliance or a network gateway, the virtual network, the internet, or none of it. After that, you need to associate that specific route table to a subnet. Remember that you can specify also service tag as an address prefix instead of using an explicit IP range. So now let's take a look on how to create a route table, add a route to it, associate the route table to a specific subnet, and explore the effective routes. In this demo, we're going to create a user-defined route by creating a new route table. So we're at the virtual network overview, and the routing piece is just going to create a route table. We're going to select the resource group that we have for all resources, and I'm going to name this route table as user-defined route 1. So later, I'm going to define if I want to get the routes from on-premises or not propagated to the subnets where I'm going to associate this table. In this case, I'm going to say no because I don't have any on-premises environment. And in here, we're going to select West Europe because that's where the subnet is. So let's create this route table. And after that, we're going to configure what is going to be the route that we want to propagate into the subnet. So let's imagine that I want to get into a different spoke. So this is the hypothetical route that I'm going to add into my destination here. So it is going to be an IP address. Let's say that this spoke network, it is in the 10.1.2.0/24, and the next hop type is where I'm going to send or I'm going to jump after I want to reach this specific network. So I can choose if I have a virtual network gateway, a virtual network, internet, virtual appliance, or I can just say none. And there is basically not going anywhere. I'm going to choose virtual appliance because later I'm going to use Azure Firewall in another demo. So we created a dedicated subnet for that, and it was located in the 10.0.1 address space. So I'm going, for example, think that the firewall is going to be available in the 0.5 address, and I'm just going to add that. So basically what I'm saying is that if I want to reach to the 10.1.2.0/24, and the next hop or the next jump is going to be the 10.0.1.5 address. So the next thing I need to do is that I need to associate this route table to a specific subnet. So I have a subnet where is the spoke 1, and that's the one that I'm going to use. So I'm going to associate that subnet into that specific route table. So what we're going to do next is that we're going to review the effective routes. In order to do that, I need to take a look at one of the virtual machines that I have in my environment, and specifically the ones that I have in the default network. And what we're going to do next, after that we check that, is that we're going to review the specific effective routes. So we're going to search for network interface cards, or we can close this one and come back to the network foundations, look at the network interfaces that we have, and then we can just search them in the Azure portal. So in here, I have two virtual machines that are on the VNet Spoke network. So any of the two are going to be just fine for the exercise. When you're looking at the network interface, you can see different configurations that you can have here. But what we are most interested right now is on the effective routes, because in that way, we can also take a look of other things that we have available in here. So what you can see in here is that we have the associated route that we just created, and we do have that information. But not only that, we also have the system routes that we were talking about just before in the presentation. So we have the default network for my own virtual network, which is 10.1.10/24. We have the peering that we created with the hub network, which is 10.0/16, and also the one that goes to the internet, and we have others available here. So at the end of it, I can see my user-defined route that is saying that if I want to go to the 10.1.2/24, it is going to send me to the 10.0.1.5 address, which is where my Azure firewall lives. And with that, let's go back to the presentation. When you're communicating back to on-premises network, you need to know what is the destination routes and what are the receiver routes in both ways. In order to do that, we need to update those routes, most likely manually, in order to gate those changes. But that doesn't need to be like that. So we can implement Azure Route Server to dynamically update the route tables when there is a network address change. With this, you don't need to worry about changing your route tables manually. But remember, Azure Route Server will require a dedicated subnet, and your network virtual appliance needs to support BGP, or Border Gateway Protocol. Let's imagine that you have lots of Azure virtual networks, and managing them, well, can be a hassle. So you need a change here, you need a change there, and maybe you are going to make mistakes. In order to avoid that, we have Azure Virtual Network Manager. So in here, you can group those virtual network resources together and create a connectivity configuration or maybe a security configuration, and then you can apply those changes accordingly, making managing your virtual networks easier. Sometimes your Azure virtual machines need access to the internet. You can create a user-defined route and send all the traffic back to your on-premises proxy server, or you can create an Azure NAT gateway. With Azure NAT gateway, you can give these virtual machines outbound access to the internet while remaining fully private. This concludes our session. Please review the following slide to remember some of the topics touched in this video. Pause the video now and read the questions out loud. Are you able to answer them? I hope you can. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out for your next favorite topic on Microsoft Learn at aka.ms/learn.